over to ECHO's co-founder and president, Mark Lai.
Good morning. Thank you, Chanel. And thank you all for being here today. It's, welcome to this seminar on avoiding environmental setbacks during construction. My name is Mark Lai, and I'm the president of ECHO, and it's my great privilege, really, to introduce today's session. For those of you who don't know much about ECHO or aren't very familiar with who we are, I just want to take a minute to tell you a little bit about who we are before I introduce today's session and today's speaker. So last year, 2020, we celebrated 20 years in business. So I know 2020 may go down in history as the worst possible year to celebrate anything at all, but actually we are, thrilled to have to be able to boast 20 years in business, and it really is a testament to, I think, the amazing team that ECHO has. So, back in 2000, the three partners, of which I am one, so the other two are John Lewis and Om Malik, Dr. Om Malik, I should say. We each had our own consulting firms, small firms, and each of us were specializing in the various, our own sort of expertise. I can't really see which slide we're on, but Matt, if we are on the who we are, that's where I'd like us to be right now, because it really is these three pillars of service that represent kind of our expertise as a firm. And it also is kind of the history of how ECHO came about, because each of us, the three partners, had our specialty in these three different areas. So my own background was in hazardous materials, and I had started a firm to deal with hazardous materials in buildings. And back in those days, there was a lot of work, especially surrounding asbestos. And of course, there still is even today. And but in those days, a lot of companies were just specializing in one thing or another. But I found increasingly that my clients were really looking for kind of a, help addressing a more comprehensive approach to solving their environmental challenges. So I would be drawing on, the people that I knew and had respect for to help me with the various issues. So when I had clients that required environmental services, such as phase 1s, phase 2s, phase 3s, or remediation type services around subsurface contaminants, I would draw on John Lewis. And that was his specialty, what we call the environmental component of ECHO. And around that time, also, I got to know Dr. Om Malik, who had recently retired from the Ministry of Labor. And he was a very well-respected hygienist, still is, and was brought in to help kind of mediate one of the largest mold remediation projects in Ontario, and that was the Newmarket Courthouse. So I got to know him at that time, and of course, Dr. Malik is a multi-talented fellow. And I found I could really draw on him for any kind of occupational health and safety issues, including mold, but other occupational health and safety issues. And so the three of us really got together and we started this company, ECHO. And we're now proud to say that we're a 70 plus firm with offices in Mississauga and in Ottawa. And we do service our clients right across the country, but those are our two existing offices right now. So those are the three sort of pillars of service that make up ECHO. And really, it's, as I said, it's a testament to our team, of which Matt Lainville, who's today's speaker, is one. And I've been consistently impressed with Matt and his kind of breadth of knowledge and interest. I mean, Matt is one of these guys who is just hungry for knowledge, and he's, you know, fabulously curious about all things related to the environmental sector that we find ourselves in. So, you know, Matt really, I think, personifies kind of the great team that we have at ECHO. He is our team lead and manager of the Ottawa office. And today I'm thrilled to introduce you to Matt Lainville, who will take it from here. And I hope you enjoy the webinar. Matt.
Excellent. Thank you, Mark and Chanel, for those kind words, and everybody. Good morning. What we're going to be discussing today, the topics of this webinar will include some items such as common environmental issues encountered on construction sites, such as mold, asbestos, lead, PCBs, and we'll dive a little bit into abandoned chemicals and laboratory decommissioning, just as a spice it up a little bit. Within these things too, we'll be discussing the potential impacts of unaddressed environmental issues and best practices during design and construction to minimize environmental impacts. So let's start by defining what an environmental setback may include. An environmental setback may be defined as a previously unknown condition, which may result in schedule delays, budget increases, health and safety issues, including stoppages of work. And for today's presentation, we'll be focusing on renovation projects rather than new builds. The setbacks may include, but are certainly not limited to, the designated substances, which we will expand on in the next slide, special handling materials, mold, chemicals, and wastewater. So an environmental setback is basically any environmental concern which was not originally identified prior to the start of work. And common environmental setbacks observed during construction often revolve around designated substance, as I mentioned. And throughout this presentation, we will look at the common designated substances and other environmental issues that may be present at your construction site. So let's start off with the designated substances. We'll start off with a little bit of defining each item, and then we'll jump into some case studies that will help us illustrate how these items can be setbacks on your construction projects. So designated substances are chemical, physical, or biological agents designated by the Ministry of Labour to be of importance in protecting the health of Ontario workers. These designated substances are identified within Ontario Regulation 490-09, which covers the following 11 designated substances, or which covers the 11 designated substances. Historically, designated substances were designated due to their relatively high toxicity, or in other words, it doesn't take much of this stuff to make us sick. So as previously mentioned, there are 11 designated substances identified by the Ministry of Labour in Ontario. Today we'll be discussing the 3 most prominent designated substances with regards to potential issues with construction. These include asbestos, lead, mercury. This is not to say that other designated substances are not present on the site. They're just generally encountered in quantities that are lesser concern on typical construction sites. So that being said, other materials that may be of concern that are not included within the list of designated substances are often referred to as special handling materials, and they may also be present on your construction site. Special handling materials may not be subject to specific regulations. However, the employer nonetheless must protect workers from exposure to hazardous agents. So the employer must control airborne concentrations to be below established occupational exposure limits. Example of these special handling materials that may be present on your construction site include, but are certainly not limited to, PCBs, chemicals, mold, and wastewater. There are many other items that could make this list, but for the purpose of this webinar, we're limited to the above examples and will be discussed in the upcoming case studies. So before we get into the nitty-gritty of the case studies, let's define some of these items. So we'll start with asbestos, the one that almost everyone, I hope, should be familiar with at this point in time. And you might be wondering, why is this product in everything? Well, asbestos was added to products for the following reasons: its strength properties, thermal properties, corrosion resistance, chemical resistant and was readily available at the time. So strengthening agent kind of goes without saying, it's added as a binder to strengthen materials. So you often find it in plasters and things like that. Excellent thermal properties. So without question, it's usually found on certain pipe insulations and boiler insulation materials. It's corrosion resistant. So it's resistant to weathering and chemicals, which led it to be used widely in laboratories as well, as it wouldn't be degraded by the chemicals used in the fume hoods, laboratory benches, and related HVAC systems. So we'll just get into a few examples. I'm sure a lot of people have seen these things before, but asbestos can be found in the following products that may be present on your construction site. Vermiculite, whether it be loose fill vermiculite or a material called vermicrete, which is usually base coat plaster that has vermiculite added to it. It can also, asbestos cement pipe may be present on your site, pipe insulation, siding, that would be transite board. Usually siding is reserved for residential work, but sometimes transite board can be also found as backer board for electrical items, walls, board installation. Asbestos is also found in floor tiles, sprayed fireproofing, plaster, drywall joint compound, acoustic tiles, caulking, texture finishes, refractory materials, so materials within boilers or kilns, items that are subject to high heat regularly. And the list can go on, and unfortunately, I don't believe we have enough time to continue defining where asbestos can be, but I think the image is clear that it's in majority of materials that may be present on construction sites. So unidentified asbestos can cause numerous issues on construction site, including health and safety issues if a material is unknowingly disturbed, as well as schedule and budget creep. So increasing cost, labor, and disposal when these materials are identified. And it's important to understand the building you're working in prior to construction. It is recommended that prior to initiation of construction, a gap analysis and thorough surveys be performed in an attempt to identify any of these hidden items on your construction site before they become issues. So that includes going through historic reports, walking through the site, identifying the scope of work, and any materials that may be potentially disturbed. That is a good practice to take, as oftentimes as buildings age, they go through renovation. So there's many cases where these asbestos containing materials may not be visible to the naked eye, and they may be covered with newer materials such as plaster covered by new drywall, which is non-asbestos containing, previously insulated pipes with asbestos wrapped again with fiberglass insulation. Things like that are often present on sites, and it's something that typically most people on site will not want to encounter. So it's best to try to identify these materials as early as possible, that we can include this in the design and construction phase, so safe handling and removal can be worked into the budget and schedule. You might think the newer building you're working in is asbestos free, but you may want to think again. Asbestos products are still, may be still used in construction when there's not a suitable replacement. So as I mentioned previously with laboratory fume hoods, benches, and HVAC components, up until recently, transite cement pipe was often used for these materials given its resistance to the chemicals. Regardless of it being banned early on, it was still quite widely available and used. So now that we've had a little bit of a refresher with regards to asbestos, this leads us into another environmental issue that may be present on the site, which is lead. Again, with asbestos, you might be wondering why is lead in everything? Well, here's some reasons. It was, again, widely available at the time. It has a low melting point, which made it easy to work with when it came to forming. High density, it also is capable of blocking sound, durable, again, prevents corrosion. It was added to paints to brighten the colors, so reds and yellows and things like that would stand out a little more. It's very abundant, easy to extract, easy to shape, so it's malleable material. Blocks radiation, great for that, depending on if you have radiation present on your site, or even norm risks, which is naturally occurring radiation. It's also been known to kill mold and mildew, and it helps paint dry faster. So as asbestos, we'll just go through a few items where lead may be found, and this includes gaskets. Automotive world definitely used quite a few lead gaskets, counterweights, so within windows or doors, batteries, pipe packing, so the bell joints are often packed with some malleable lead, acoustic baffles, again, goes to the sound deadening properties of lead. So common environmental setbacks that may be encountered around lead or other heavy metals include discovery of lead-containing materials during construction. So we may identify lead paint as the project is ongoing, and this may require a swing in work practices and potential disposal implications, causing delays for follow-up trades due to additional work procedures. So if you're identifying a place that needs an item that needs demolition that's covered in lead paint, this may impact your schedule because the proper procedures will be required to remove this material prior to follow-up work. Additionally, unknown hot removal of lead-based paint, so hot cutting, whether that be torching, grinding, heat removal, may potentially contaminate the work area. So unknowingly disturbing these lead-containing paints through these methodologies may result in your work area being contaminated, which ultimately may require cleaning and decontamination to move forward. And this brings us to abandoned chemicals and laboratories. Again, we'll do a quick little definition of what some of these items might be. And when it comes to the use of the historic use of the building is key in identifying potential environmental health and safety issues. So it's if you're working in something like a laboratory or where chemicals were present, it's very important to understand why they're there, what they were there for, and what their uses were and who was using them. So abandoned chemicals may be present on your site or residuals from these chemicals. For example, a chemical that will certainly cause issues during renovation is the presence of perchlorate crystals. So this is crystallized material that results from the use of perchloric acid. And these crystals are considered shock sensitive. So bumping or hitting them will cause an explosion, which of course no one wants on their site due to the numerous issues that will follow this incident. So for instance, if your project requires the decommissioning of laboratory equipment, it's imperative to attempt to obtain this information. And if you can obtain this information, it's always best to err on the side of caution, as delays may be encountered if these items are identified either during construction or unfortunately, if somebody accidentally bumps them and has an incident causing health and safety problems. Another item I'd like to touch on, which is common sometimes on construction sites, especially larger sites, is wastewater. So wastewater can be defined as any liquid that is present on site requiring removal or disposal to access work items. So a good example of this would be a chiller system or HVAC components that are generally having water through them, typically with some sort of additive, corrosion resistant additive or something like that, that makes it not just plain water anymore, it's becoming a wastewater concern. So for the purpose of this webinar, we'll be discussing wastewater with regards to chiller and mechanical systems. Stay tuned for further webinars with regards to groundwater and dewatering processes, as that is kind of a separate topic with regards to more new construction and environmental subsurface work. So wastewater is often assessed at the time of disposal. However, thought should be given at the planning stages as options for disposal are present, and they may alter budget depending on applicable waste streams. So for instance, Ottawa has a sewer use bylaw, which exists not just in Ottawa, but in many cities. And as a result, what can happen is that we can sample the wastewater and apply it to these regulations to determine what waste stream is required. So depending on what additives are in your wastewater, you can even get approval from the city to dispose of this material through the sanitary or storm sewer. Storm sewer can be as simple as spreading the material on the ground, depending on the contaminants present. So it's always best to sample water prior to disposing it for the following reasons. Non-approved disposal may result in fines, or assumed disposal of hazardous waste, or if you're assuming your wastewater is contaminated, you're going to incur additional cost with special waste handlers and disposals as hazardous waste. So another topic, which again has been encountered on many construction projects that I've been a part of, is mold. And I'm sure that nobody's new to this item. It's been around for a long time and it makes the news quite regularly. So this is often an item that lurks in the shadows. We often think we understand what mold is, and with any luck, you attended our previous webinar put on by Rob Fernandez last month, which will give you a great understanding of mold. And it's also available on the website if you want to return to view that presentation. So a brief overview of molds. Fungi is a single-celled organism that absorbs nutrients from their environment. They're simple microscopic organisms, and they're found in every ecological niche, so indoors, outdoors, necessary for recycling of organic materials, and they need external food sources. So things like paper backing on drywall, paper wrap on pipe insulation, things like that are all very good sources for mold growth. And given that mold is not always obvious, it may be included as part of a pre-renovation or demolition designated substance survey, which ECHO generally includes as part of their survey. This allows for proper planning and implementation of programs prior to construction. And a trained inspector will not only look for mold, but other signs of water damage, which may give indications that mold are present. So bubbling paint, signs of high humidity, for instance, condensation on windows, and things like that are what to look out for signs of potential mold growth. And mold growth may not exhibit itself on the visible surface of a building, however, it could take time for that to occur. However, it may be present within the wall cavity, and it just hasn't had the opportunity to display itself on the visible surface. This topic will be discussed in one of our case studies. And our last item of concern, which is more of the special handling item, as I mentioned before, is PCBs, or polychlorinated biphenyls. Most people know them as PCBs. They belong to a family of organic chemicals known as chlorinated hydrocarbons. They're typically industrial chemicals, and they are odorless, clear to yellow in color, and are highly toxic to organisms. So here's a few examples of where PCBs can be found. PCBs may be present in equipment left on site, for instance, transformers, fluorescent light ballasts, high voltage wiring. There's a PCB impregnated coating typically found in some high voltage wiring, and also caulking and industrial paints. And typically PCBs were added to caulking and industrial paints for elasticity purposes. However, this was prior to our knowledge of how detrimental PCBs were on the environment. Okay. So now that we have a little bit of a base knowledge on some of the more environmental concerns, we might be asking, well, what does this mean for us? Well, let's examine what unidentified items may cause for your site through the following case studies. We will examine some of the encountered environmental issues and their effects, which may include worker health and safety, refusal to work, stop work orders, fines, project delays, and budget overruns. Not to mention, any of these items may result in negative impacts to reputation and may garner unwanted media attention. So this brings us to our first case study. So this is revolving around a central heating and cooling plant, which suffered a catastrophic failure of a boiler, which resulted in an explosion and spreading. As a result, asbestos-containing materials were spread across the entire facility. Obviously, the environmental issues created by the explosion were unavoidable. However, due to lack of thorough investigation and training, environmental issues and setbacks continued throughout the duration of the project, which included budget creep and schedule delays to address these issues. So we'll be talking about a few different environmental issues with regards to this project, and we'll start first with asbestos. So as a result of asbestos-containing materials being strewn across the facility, the entire facility was subject to a cleaning program to facilitate safe entry and to isolate the boiler side, which was the side of the building which suffered the catastrophic failure, from the chiller side of the building, which was still in an operational state. Following this cleanup, the boiler side of the facility was placed under a type 3 asbestos abatement containment. So shower in, shower out, negative pressure, continual air monitoring was required outside the containment to ensure people without asbestos safety precautions were not being harmed. This was done to, again, clean this facility and also to demolish the damaged boiler under safe precautions, as it was unknown if internal materials of the boiler were asbestos containing at that time. So during this time, it was requested that additional investigations be performed on the remaining boilers to identify any potential asbestos containing materials that may be contained within the wall cavities and ceiling cavities. As these boilers were also scheduled for demolition, it was best to try to identify these materials before exiting the existing type 3 containment. That way they could be dealt with within the same containment and not have to return to the site as type 3 precautions. So during this time, we performed inspection openings within these remaining boilers to determine the internal construction. If there were refractory materials were present, what kind of materials were they, and if any of them were asbestos containing. So what was decided was that openings would be performed in the sides and corners of the boilers, and it was recommended that the tops of the boilers also be inspected as well. At the time of the investigation, the boiler tops were not cut open as it was an access issue, and it was decided that the inspection openings on the sides and corners of the boilers were sufficient enough to continue on with the project. That being said, none of the materials from the sides or corners of the boilers were found to be asbestos containing, and therefore, when the project continued, the asbestos abatement precautions were lifted. Or in other words, the site was turned to a clean demolition state, which I like to refer to as demolition not connected to hazardous materials. So on the very first day of clean demo, a worker began cutting open the top of the boiler, and lo and behold, it was discovered that asbestos containing magnesium block, or mag block as it's often referred to, was present within the entire top surface of the boiler. As a result, clean demolition was halted and asbestos abatement precautions were reintroduced to the site, and each boiler was dismantled by hand under type 3 asbestos abatement conditions. This resulted in a large budget overrun or extra and scheduling implications lasting up to 6 to 8 months in order to demolish these boilers by hand, and upwards of $3 million in extras. In addition to the already mentioned delayed, now that we are removing the boilers by hand under type 3 conditions, all materials leaving that containment required cleaning. That included all scrap metal, which was required to be tested before leaving the site for residual asbestos contamination. That included wipe sampling of representative materials within scrap metal bins, and then submitting wipe samples for analysis to determine if they were clean or not. This often led to delays in removing of waste and turned the site into somewhat of a bin parking lot, as there was just more metal than you could deal with, and we couldn't get it off the site fast enough due to the condition of having to test it prior to disposal, which was requested by the waste receiver. So in addition to the boiler findings, asbestos containing materials were also continually disturbed on site without proper precautions. So due to lack of awareness and faults in communication, as the site conditions were forever changing, the investigation was ongoing as the work was continuing, as this was basically an emergency project, and the heating plant served quite a few buildings in the area. And not to mention, there was multiple projects on the go at the same time. As I mentioned, the chiller side was still operational. There was still work ongoing there as separate projects, and not to mention the construction of a brand new boiler heating plant was occurring adjacent to the site. So 3 different projects within one facility were crossing paths on numerous occasions where pipes had to be tied in or removed to allow other projects to proceed. So an example of this occurred one day when workers were removing gaskets from pipe flanges to facilitate the connection of the new boiler systems to the existing pipes systems. The workers used an angle grinder to remove the gasket. And prior to completion of this, someone walked by and mentioned it may not be a great idea to do that as the gaskets may contain asbestos. Unfortunately, the work had already been predominantly completed and the gasket had been pulverized and turned to dust and was strewn about the work area. Now, following this gasket was sampled to confirm that it contained asbestos, and as a result, the work area was shut down for approximately 1 week while asbestos abatement, or cleaning in this case, and air sampling was performed, which in turn prevented any further work from occurring in this area. So we had a project delay with regards to reconnecting services to the building because of this. And at this point, communication became vital across the 3 projects, as it was becoming a little apparent that workers may not be being made aware of new discoveries as the project progressed. So as I mentioned, the investigation was occurring as the project progressed, and many items were changing from day to day, and communication may not have been as efficient as it could have been across the 3 projects, which just allowed for more delays and concerns with regards to environmental issues and health and safety. So that being said, from moving that forward, every gasket in the facility had been considered to be asbestos containing, which allowed for workers to no longer just damage the materials with power tools and without precaution. Okay, so following these items, or the discovery of these items, we shifted mentality on the project, or project players shifted mentality to leave no stone left unturned sort of feel. And this was to prevent further delays and with regards to schedule. Monetary costs could not be obviously reduced. However, with generally allowing for investigation and removal of these products prior to follow-up trades, it allowed the schedule to continue as required. So not only was asbestos an issue with regards to case study 1 in the heating plant, but lead was also a major issue as we proceeded with demolition. So lead-based paints were widely present at the site given its age. It was considered to be the oldest operational boiler plant in Canada at the time. And the discovery of lead paints resulted in the development and implementation of lead abatement procedures, which delayed demolition, as now that all the containments or all the boilers were required to be demolished by hand, it required high temperature cutting and appropriate PPE and engineering controls with regards to lead abatement. So it doesn't sound like the end of the world, does it? Like we're already under type 3 asbestos conditions, you know, adding a little bit of lead precautions in there, not the end of the world. But what was not anticipated was the amount of high temperature cutting that would be required, as the initial plan was to demolish the boilers using machinery rather than hand demolition. So removing it by machinery would have allowed for less of a lead risk, and it would have been completed in a more timely manner. So as you can imagine, an excavator with a grapple on it or a snipper would be much faster than 3 or 4 individuals with torches, keeping distance and maintaining safety at all times. It slowed the project down quite a bit. And also due to this use of high temperature cutting, engineering controls and lead abatement, lead paints were vaporized, and that vaporized material tended to spread throughout the facility quite easily. This issue was not addressed immediately. However, it was brought up that before the building would be turned over, it would be cleaned for lead and tested to ensure that the lead contamination was removed. Another issue that surrounded this facility and lead was that the specification was written in such a way that the lead criteria was considered to be very low. So it was almost as if it was trying to be set up for a daycare where a child could go in and crawl around and lick their hands after and without much concern. However, given that it was a boiler facility, it should have been considered an operational area, which would have increased the lead criteria and likely would have reduced the amount of cleaning time, as the reduced lead criteria led to many failures in confirmatory sampling. And then as a result of that, additional cleaning was required. And that added approximately 2 to 3 weeks of additional time on the schedule. So this brings us to case study 2, which is an example of what I like to call doing it right. So this case study involves a government building which was previously used for metallurgy research. And the plan was to use this building as a swing space. So office space for public servants while another space was being prepared. This facility, of course, as I mentioned, contained a working foundry for metallurgy research. And prior to its shift in use, it was recommended that a thorough investigation be performed with regards to potential environmental and health and safety hazards. So this investigation included chemical sampling, but also sampling for heavy metals associated with the historic foundry use. That includes wipe sampling for lead and other metals, and sampling for mercury, which often gets trapped within plumbing systems. That's very dense. It stays within the P-trap system. So we did a very thorough investigation of all drains within the facility, as well as sinks, floors, just to determine if any residual mercury was present. And also, if you recall, I mentioned perchlorate crystals earlier. Well, in this case, it was undetermined if perchloric acid was used in the facility. So that being said, it was added to the risk assessment, just given the unknown. And with regards to that, required wipe sampling of interior fume hoods, fume hood ventilation, and laboratory benches for confirmatory purposes. Now, based on this investigation, it was discovered that lead contamination was present throughout the facility, and was discovered that lead levels were considered to be quite high, even at the farthest reaching corners of the building. So farthest away from the foundry, nowhere near the metallurgy research area, it was still determined that lead criteria was quite high, or lead contamination rather, sorry. So due to this thorough investigation, it was thankfully discovered that the building was not suitable for swing space without a thorough cleaning, which would have involved quite a bit of finance input and also schedule delays, as the swing space was required sooner than could be provided. So this is an example that shows it occur with proper planning and investigation. The information derived from that initial survey was not put to waste. Thankfully, it was used during the building demolition and was included in the design phase of demolition to determine appropriate waste streams and decontamination procedures and demolition methodologies to ensure environmental setbacks were addressed prior to becoming issues. So that brings us to case study 3, which consisted of a large multi-building complex undergoing major renovation across multiple buildings. This included a complete gutting and rebuild of the majority of buildings and the demolition of some buildings in their entirety. This site encountered an variety of environmental issues, which were initially reacted to as they occurred as the project progressed. After this few months of progressing this way, it was determined that a proactive approach would be better to reduce schedule and budget creep, and remaining buildings were investigated prior to trades entering to perform the work. So the initial designated substance reports that were provided were considered superficial in nature, as they were performed when the buildings were occupied and did not encompass the entire scope of the renovation project, as it was not determined at the time of the initial survey. So the surveys were performed without knowing entirely what the scope would be. In addition to this, the previous surveys, as I mentioned, were non-superficial, which means non-intrusive. So an intrusive investigation would be opening up walls and ceiling cavities in order to identify building materials that may be present. So as I mentioned earlier, with asbestos, sometimes it gets covered up. Pipe insulation gets rewrapped with fiberglass. This initial intrusive investigation would allow us to attempt to identify all these materials by creating openings into the wall and ceiling cavities, removing pipe insulation to ensure that fiberglass is the only insulation present. So during the course of this project, many of these hidden conditions were identified for asbestos, such as transite board, plaster, pipe insulation, all covered with non-asbestos materials. In addition to that, lead-based paints were also present because of the age of the facility. Now, what would have been ideal in this situation would be to conduct a pre-demolition survey, which would have included for the creation of inspection openings to see within solid wall and ceiling systems for potential environmental issues. In this case, it was mainly asbestos. As they were office buildings, no laboratory chemicals were being used at this facility. As a result, this initial response was to sample newly identified materials and react as needed. So as I mentioned, the initial project started as a reactionary. So a worker would remove a drywall wall, and lo and behold, there'd be asbestos behind it, or a plaster containing asbestos behind it. That would initiate the reactionary methodology, and we would sample the material and remove as required. Reacting to these items often causes schedule delays and potential problems with follow-up trades. And of course, anything delaying schedule typically increases budget as well. Okay, this approach was also used with regards to mold contamination at the facility. So any wall and opening ceiling cavities we opened were also inspected for mold. And knowing these buildings had previous building envelope issues, so in other words, window leaks, roof leaks, aging roof membranes, this was added to the list, knowing that there's a potential for mold contamination present. So this stage, the mold investigation occurred early in the construction process in the buildings that had not yet been worked on. And we were able to safely and effectively remove these materials prior to the follow-up trades entering the building, and thus not affecting their schedule or their budget. In addition to the mold and asbestos identified at the site, like I said, lead-based paint was also observed in various surfaces scheduled for demolition. Now, prior to the demolition of these materials, demolition practices were reviewed, and it was determined that rather than using hot work, which, as discussed in case study 1, is not the best way to remove lead paint, it was decided that the painted materials could be disassembled, so taken apart by hand, and disposed of with minor lead precautions. So as very little disturbance to the paint was required, this allowed for the safe removal of the structures, and it also allowed for the area not to require isolation. That means that trades working in the area not associated with the demolition could continue to work in a safe and effective manner. Again, this is another great project because it also touches upon wastewater disposal. So as the project progressed, it was noticed that wastewater disposal was becoming more of a requirement to facilitate work on the chiller and HVAC systems. The wastewater in this case was consisted of 3 million liters of chiller water that had an anti-corrosion additive added to it. So basically city-derived water, 3 million liters of that with a corrosion inhibitor added. The following discussions with the project team, it was noted that wastewater disposal at the site was being performed by a specialized waste disposal company and was incurring great amount of costs associated with it, as wastewater is not a cheap material to dispose of. Because of this, it was recommended that the chiller water be tested and compared to the City of Ottawa sewer use bylaw to determine if disposal could occur through the storm or sanitary sewers. Upon receipt of the results, it was determined that this water could be discharged through the City of Ottawa sanitary sewer without additional fees. Depending on the contaminants in the water, you can also discharge it with surcharges. So if you have contaminant X, a surcharge of Y may apply, but it's still a possibility. So based on this finding, we were able to dispose of 3 million liters of water through the City of Ottawa sewer system without any additional cost. We did incur some schedule delays, as the 3 million liters took about 5 days to dispose of. However, the savings for disposal far outweighed the schedule implications. So it's a good example of being able to thoroughly investigate your building prior to construction or demolition of these materials in order to get a good scope of what's going on, and you can, move forward appropriately, whether it is regarding disposal of materials or removal, so proper procedures and PPE. Okay, this brings us to case study 4, which again is a nice example of doing things right. It is regarding the laboratory decommissioning. This research laboratory was used for various research and manufacturing purposes with regards to satellite communication. And it was scheduled for decommissioning so the space could be turned into a fitness center. So a consultant was called in at the design phase and was given access to facility records. And was able to interview staff. So interview staff, meaning current and retired staff, were interviewed to determine what chemicals would have been used on site. And this was all done prior to arriving on site for the investigation as a gap analysis. But once it was determined which chemicals were used in the space, a sampling strategy was developed with an industrial hygienist, which set the framework for the assessment. The assessment for these materials included the removal of a raised floor within the laboratory where the semiconductors were manufactured. The initial review indicated that heavy metal contamination was present in the form of lead, mercury, and arsenic. So lead and arsenic were due to the historic production of semiconductors. Semiconductors are basically a combination of gallium and arsenic, or also known as gallium arsenide, which is generally considered to be a carcinogen since gallium arsenide can dissociate into gallium and arsenic, which is a designated substance. So in addition to the gallium arsenide, it was also noted that mercury-containing equipment was widely used at the site. And because of this, it was presumed that mercury may be present beneath the raised floor. And again, as I mentioned earlier, with any drains or P-traps in the area. And once these hazards were identified, the appropriate work methods and PPE were prescribed to deal with the contamination. And this was all done following the ASTM standard for laboratory decommissioning, which allowed us to plan and include in the budget and schedule the removal of these contamination and hazardous items. So this case study offers up an example of leaving no stone left unturned and identifying all hazards prior to beginning of construction. This is obviously an ideal scenario, and it doesn't occur on an everyday basis, but it just gives you an idea of what can be achieved if you attend a site prior to and get the full understanding of what's going on before tendering and even shovels hit the ground. So ways to avoid setbacks, and what have we learned? Well, based on going through some of those case studies, we have learned that training is very important this is extremely important with regards to allowing individuals on site to identify any potential hazards or issues prior to them becoming setbacks. For instance, if a worker had been trained in asbestos awareness or designated substance awareness, they would have the knowledge to be able to stop and reevaluate a situation where suspect asbestos or hazardous materials are present. This would be prior to the creation of a health and safety or environmental issue. So prior to the disturbance of the material, which, as mentioned, occurred in case study 1 on a few occasions, but with the gasket removal being the example we utilized. Also, a thorough investigation of building use will allow anticipation of environmental issues and with any luck will allow for correct handling of potential environmental issues to prevent unknowing scheduling and budget concerns. Or in other words, it may help us anticipate and react to environmental issues before they become setbacks. So as I mentioned with case study, the government complex, we managed to get in there before other trades to remove the hazard, which allowed them to complete their work in a timely manner without any sort of delays. Also, things we can take away is a review of construction practices with the investigation information in mind. So following the completion of intrusive and thorough surveys, it's generally a good practice to review construction and demolition practices, as displayed within case study 3, where lead coating materials were dismantled rather than torched apart. Again, this allowed for minimal risk with regards to lead exposure for workers within the building and prevented residual contamination, which may have occurred due to the torching of materials coated in lead paints. Due to this change in procedure, there was no requirement to cordon off the areas or implement lead-related PPE or engineering controls other than personal hygiene. So this resulted in no delays, and project schedule and budget remained in place. And okay. So with that said, I'll end off with a few quotes as takeaways. So an ounce of prevention is worth a pound of cure, or in other words, taking time to fully understand your construction site with regards to environmental concerns may prevent any setbacks. And additionally, you can't control what you don't know. So for instance, you can't implement health and safety controls, required PPE or engineering controls for environmental concerns or issues you are not aware of, which will lead to health and safety concerns, stop work orders, all of the above. That being said, that brings us to question and answer. So if anyone has any questions and answers, I'll let Chanel jump in here and help moderate where we go from here.
Okay, so if you do have any questions, please be sure to add them into the question and answer section or into the chat. I see we've gotten one so far that Mark has answered. I know we are cutting it very close, so if you do have any questions and we don't get to them, feel free to send them in an email to Matt. His email is on the screen right now, along with his phone number and contact. That being said, the first question, sorry, that we got that we've already answered, but just as general knowledge, was, are hydrocarbons designated substances? So Mark has already answered this, and he said that it's not a designated substance, but other hydrocarbons are not part of that. So in general, they're not typically part of an assessment, but they can cause an environmental setback if they are being used. The first question I'm seeing in the question and answer section is, which laws can be consulted when deciding, while deciding wastewater disposal method?
Okay, so the laws that can be consulted while deciding wastewater disposal methods would typically be the sewer use bylaw is probably the biggest one. That will determine the waste stream required. So if it doesn't apply to the storm or sanitary sewer, then the materials would likely be disposed of as hazardous waste, which would require some further investigation to determine the waste stream and also where it can go. So it requires special handling procedures, and for instance, companies like Veolia, Drainol, they handle most of those procedures and have facilities to control this water. But as far as laws go, wastewater disposal, the big one is probably the sewer use bylaw, as I mentioned, because it allows an individual to save time and money, essentially, to put it down the sewer. And if it doesn't apply to that, then you have to look at the hazardous waste regulations and things like that, which it's quite a road to go down. And you can get into things like leachate toxicity and all that. Unfortunately, we don't have time to touch upon all that, but yeah, if that doesn't answer the question, I'd be happy to discuss this anytime further.
Awesome. Another question we got is, can you speak to asbestos regulations in Ontario? Are they no longer allowed to be installed in Ontario, both friable and non-friable?
So yeah, the asbestos materials are banned obviously. Well, I shouldn't say obviously, it was banned years ago, but yet we continue to use them. So this is something that's changed recently, and the government has taken action into not allowing these materials to be used any further. However, you may still encounter transite pipe and things like that, even in buildings that are from the late 90s, as there was no suitable material present to replace them. That being said, it's often a non-friable material that will still be used, for instance, like the transite pipe. Yeah, typically that's what you can still find to be present in newer builds. New builds, they shouldn't have any of these materials present, as suitable replacements have typically been found.
Awesome. The next question we have is ammonia used as a refrigerant, controlled substance? Can it be discharged into the atmosphere? Is it a requirement versus best practice to reclaim the ammonia?
Yes, I would recommend not discharging to the atmosphere. I am not an ammonia expert. I would have to refer to probably an industrial hygienist or even an environmental scientist with regards to that, as discharge to the atmosphere would require a certificate of approval. I would say best practice would be to reclaim that material and recycle or dispose of as required.
Awesome. I have another one. What hazardous substances are typically found after a fire?
That's a good question. That we could talk about that for days too. So dioxins and furions are big things that are typically found after fires. Asbestos containing materials are often left behind as they don't burn. So there could be a number of hazardous substances with regards to fire. Mold is another one that comes after fire, as firefighters tend to use quite a bit of water. I'm not sure if anybody's been exposed to a fire before, but often the suppression system may cause more damage than the fire itself.
Awesome. For ad hoc laboratories, i.e. drug manufacturing, does ASTM standards still apply, or are there other standards that are supposed to be used?
I've not been experienced to any drug manufacturing, but I would assume there are specified standards for decontaminating those type of laboratories, as they tend to be quite hazardous and can often lead to explosion.
Awesome. Okay, when we talk about designated substances, do we have the same designated substances across all provinces in Canada?
We do not. So for instance, Ontario and Quebec operate very differently. They do not have a specific designated substance regulation. They have more of something called hazardous materials regulations, which apply to the same materials, but it's more of a broader scope. So it's not necessarily identified as 11 materials. It's just sort of, you need to ensure that the employer is not exposing individuals to excessive exposure limits of certain of the materials. So it doesn't specifically identify these materials. However, we often apply the designated substance regulation to a lot of other provincial work, which may not have this regulation in place.
Yeah, and maybe I can just add to that a little bit. I mean, just to clarify, I mean, the designated substances have been designated by the Ontario Ministry of Labor. So it is a ministry, it's an Ontario
Ontario-centric.
Yeah. However, like many things in the country, I'm sorry if you're outside of Ontario, I know you're offended by this, but like many things in the country, I think Ontario often sort of sets a bit of the standard, and that's an example of that is really asbestos. I mean, Ontario was the first province to take on an asbestos regulation, and all of the regulations across Canada have largely been, modeled on the Ontario regulation. There are some significant differences, but regardless, I mean, much of that came from the Ontario Ministry of Labor. And I think with regard to designated substances and how we deal with them, while it is regulated in Ontario that you must really identify these 11 substances prior to a construction, it's not regulated in most of the other parts of Canada, but it has become what we could call an industry standard. Most of our clients who have national presence basically apply that approach to all of their construction projects across the country.
Perfect. We have 3 more questions left. Sorry, I know we're over our time, but I do just want to make sure that we answer those before we end off today. So the first one is, how do we control the use of imported materials that don't meet our standards? For example, magnesium oxide board from China.
That, I would imagine, is a topic for a larger discussion, as that would be a regulatory compliance thing with government input. I mean, it's possible of course, these materials are still being imported without knowledge, and it would be difficult to probably put an end to a lot of this without overseeing body really taking control.
Awesome.
Yeah. You're right. It's a long answer to that one, but I agree. Yeah, go ahead.
Awesome. Sorry. The last 2. So would you briefly walk us through a typical example of a reporting issue to the MOE in any province, really? How does this conversation typically work, even if reporting a minor instance just to be safe of the client?
Typically what would occur is, I guess, are we speaking of Ministry of Labor or Ministry of Environment, I guess?
MOE, so I'm guessing Ministry of Environment.
Yeah, so I first off, the issue would have to be identified. So let's say we would have discharge of water unknowingly to an environment. That would need to be identified first and foremost, that it occurred, and reporting to the Ministry of Environment. That would probably be a question for another one of our experts with regards to environmental issues, which would be Jeff Muir. But if you want, I can even pose that question to him, and maybe we can get a firmer answer with regards to that. So whoever asked that question, if they don't mind even presenting it to me through my email, I may be able to proceed further with that with another one of ECHO's experts.
Awesome. And just a reminder, Matt's email is on the presentation right now. So if you do need it, that's where you'll find it.
Thanks, Chanel.
Absolutely. And the last question, when conducting a DSR for insulated pipe removal, for example, do you take samples of the pipeline insulation nearby for ACM, or what do you call nearby?
So I guess it depends on the scope. Nearby could mean directly adjacent. It could mean 6 feet away. So for insulated pipe removal, if the scope is, for instance, inspection purposes, we would probably strictly look at removing that item only to prevent disturbing adjacent items, if that's the case. Now, if it's a larger project, let's say for not specifically for the pipe removal, but they're going to be working in the area, it's good to understand the scope. Let's say they're swinging ladders around in a mechanical room that has asbestos containing pipe insulation. There's a very high chance that they could damage that, which would clearly result in an environmental issue and a health and safety concern, and not to mention schedule delays. But yeah, depending on the scope, it may be best practice to remove what's around the work area, or to ensure the workers in the area have asbestos awareness training so they're not moving around without precaution.
And maybe I could just add quickly to that as well. I think, it's important to distinguish a little bit between a designated substance assessment, or DSR, or designated substance survey, and the requirement to remove, because really a survey is primarily there to inform, right? So the idea is, first you identify and you inform the workers that the material is there. So there's no actual requirement to remove it unless it's going to be disturbed. So the likelihood of disturbance comes through a type of risk assessment, if you like, where one assesses the risk of it being disturbed during the construction. So it's imperative that that everybody be informed that the material is there, and part of that is so that they can control the disturbance. Maybe they're going to disturb it, maybe they won't disturb it. If there's no likelihood for disturbance, it doesn't have to be removed.
Awesome. And that's the end of our questions. So again, if you do have any further questions, please feel free to reach out to Matt. His email's on the slide again, or you can also reach out to Echo Learning. So learning@echo.ca if you do have any further questions for us or any other input. Further, please do ensure that you are completing the webinar exit survey on your way out, just because it does help us out and continually improve. And with that, I think we are all done. So you guys have a fantastic day.
Thanks everybody for
Thanks,
attending.
everybody.
Thank you.
And thanks, Matt. See ya.